There are two lecture sets for Chapter 6, and both of them are short. We're going to start out with the first section, which talks about uniform distribution. And the neat thing about uniform distribution is the graph of it, as you can see by the picture below, is a rectangle. And probability is nothing more than figuring the area of a figure. A bell curve in the case of most of it, but in uniform distribution, it's just a simple rectangle. And if you look at the designations underneath the rectangle, you'll see A on the left and B on the right, which would be the lower number and the higher number, lower number being A. And you're trying to, and the whole yellow rectangle represents 100% of the probabilities that you're trying to solve for. And then if you want to solve for a piece of the rectangle, those would be mapped off on the rectangle, and I've designated them as x1 and x2. So not that you remembered everything about your high school geometry. If you did, you would know that the area of a rectangle is nothing more than the length times the width. So if you knew the distance between x1 and x2, whatever those numbers would be, and you knew the width of the rectangle, you would be able to multiply length times width, and that would give you the probability that you were looking for. So when we talk about continuous probability then, we would be talking about a uniform probability distribution. And if we were to lay it out on a graph, just like it did on the first slide, you would get a rectangle, and that rectangle would represent the function of x on a uniform distribution. And so the probability of the random variable assuming a value within some given interval between x1 and x2 is to be defined as the area under the graph that you would be looking for. And it would look like this. The whole rectangle would be shown in this rose color designation, and the area that we were concerned about, the area between x1 and x2, would give us, if we could figure that area, the probability for it occurring. So for a uniform distribution, the graph is a rectangle, which makes it easy, and the area is simply the length times the width. As you'll see as we get onto this, there's going to be 4 manual formulas that you're going to be able to use to be able to calculate probability of any uniform probability distribution. A random variable is uniformly distributed whenever the probability is proportional to the interval's length. And so the uniform probability density function, that's the first formula. And it sounds complicated, uniform probability density function. That's just a statistician's long-winded way of telling you how to calculate the width of the rectangle. Yes, that's what I said. The uniform probability density function is just another way of saying the width of the rectangle. And the simple formula you need in order to calculate that says to you that the function of x equal 1 divided by b minus a, with b being the largest number in the set and a being the smallest number. So once you have that information, you'll see it's very easy to do the calculation. It's rectangular shaped, and the probability, again, is the area of the defined rectangle. A is the smallest value the variable can assume. B is the largest value. And so I have indicated for you that 1 divided by b minus a, probability density function, another way of saying the width of the rectangle, is formula number 1. Okay. So that's the first of 4 manual formulas. The second one is the expected value of x. And the expected value of x is nothing more than A, the smallest number possible, plus B, the largest number, divided by 2. Don't need Excel to do that for you. It's a very simple calculation. The variance, which is the third formula, this is the hardest formula and it's still super easy. It equals the parentheses b minus a squared divided by 12. Do that and you're going to get the variance for that. And the last formula is the standard deviation. It holds true like a lot of other things do, that it's nothing more than the square root of the variance. And so here now is going to be a sample, a Slater's Buffet. And what is Slater's Buffet? It's a salad bar. Slater's customers are charged for the amount of salad they take. And they've done all kinds of sampling to learn that the amount of salad taken is somewhere between 5 and 15 ounces. And so if we now use the formula that we looked at earlier, and we start with 1 over b minus a, we're going to get the width of the rectangle. And when we substitute those numbers in, the function of x equal 1 divided by 15 minus 5. Well, 15 minus 5 is 10. And so the width of the rectangle is going to be 1 over 10, or 0.10. After we've calculated the width of the rectangle, the next thing that we're going to want to do is to calculate the expected value of x. And so the expected value of x, our second formula, is nothing more than a plus b divided by 2. In this case, a is the lowest number that x can assume. B is the highest number, so that would be 5 plus 15 divided by 2. 15 and 5 is 20 divided by 2. And so you're going to get the expected value of x is equal to 10, not point. 15 plus 5 is 20 divided by 2 equals 10. For the next one, we're going to look at the variance of x. And the variance of x is going to be under the formula b minus a squared divided by 12. So 15 minus 5 squared, it's 10 squared divided by 12. And that's going to give us 8.33. The standard deviation is nothing more than the square root of the variance, and so when we calculate the square root of 8.33, you're going to get 2.89. Again, very simple calculations. No ifs, ands, or buts, no trick questions, nothing you have to give a whole hell of a lot of thought to. It's easy to complete a probability problem when you're doing a uniform probability distribution. So here again is what we started with, and it's showing you some of the information from the stuff we just went over. You'll see that A is the low number and B is the high is the 15. Expected value 10 is the average. And so the width we calculated when we did the first problem, it's 1 over 10. You can use it as 1 over 10, or you can just convert it over to a decimal equivalent if you want. So with that in mind, what's the probability that a customer takes between 12 and 15 ounces of salad? Which is a simple problem. So now we're back to the same graph, same question, and what do we have? We've laid out on that rectangle the number 12 and 15 is the end. So what we want is the area of the box that has the x in it. And the low number for that box is 12. The high number is 15. So once we know that, and we know the width, which was 0.10, we have no problem whatsoever calculating the answer to the problem. Length times width is the formula that we're going to use. Well, the length of the rectangle, but the difference between 12 and 15 is 3, and the width is 0.10, and 3 times 0.10 is 0.3. So what you're looking at is a very simple calculation. Those four formulas absolutely, positively can take you to the solution to any uniform probability distribution problem. So I'm going to end this slide now, this lecture now, I should say, and then in a minute you'll be able to open up and work on the normal distribution part of Chapter 6.